Hello, and a wholehearted welcome to all of you in today's class. Today we shall be talking about climate and rise and fall of Indus Valley Civilization. And the main focus will be on introduction about Indus Valley Civilization, impact of climate on Indus Valley Civilization, decline of Indus Valley Civilization. Climate variably has played a vital role in the expansion and collapse of human civilizations across the world since ancient times. The Indus Valley Civilization in South Asia has been the focus of investigations to archaeologists, historians, and anthropologists. But little attention was paid earlier to the role of climate variability in shaping the course of the once well-established urban civilization. In this lecture, we will try to understand various factors that affected the evolution of this cultural enigma. The climate change in the region was a major controlling factor in determining the fate of the Indus Valley civilization settlements. The transformation of hunter-gatherers into pastoral community between 7000 and 3200 BCE, the establishment of village culture along the Indus River and its tributaries in the early Harappan phase, urbanization and shifting towards Ghaggar-Harka rivers in mature Harappan phase, and final displacement towards Ganga-Yamuna Doab region as village culture was very largely modulated by the changing strength of the Indian summer monsoon and amount of the precipitation in the region. The Indus Valley civilization between 2600 and 1900 BCE, the mature Indus Valley civilization, also known as Harappa, was one of the most developed, urbanized and widespread ancient civilization. Its major centers included Dholaviriya in Gujarat, Mohenjo-daro in Pakistan, Sindh, and Rakhigari in Haryana. It occupied an area of approximately 1.5 million square kilometers in modern India, Pakistan, Balochistan, and Afghanistan. Despite covering a huge area, the urban centers of the Indus Valley civilization showed a high degree of regularity in terms of things like measuring weights, town planning, pottery, and drainage systems. However, there was also some regional difference. Although some concurrent or earlier settlements may have existed and currently lie beneath the thick sediment deposits. According to current understandings, the earlier records of village-like communities belonging to the Indus Valley civilization are preserved in the hills of Balochistan in Mehergarh, dating to around 7000 BCE. The area was populated by Harappans and consisted a mix of Iranian farmers who arrived from the Zagros region and the first migrants out of Africa. Now let us talk about climate in Indus Valley civilization. Based on their assessment of the several pieces of archaeological evidence from Balochistan and Sindh, Sir Earl Stein and Sir John Marshall, 1931, hypothesized that climate in these areas during Indus Valley civilization period was wet than it is now 50 years ago. Archaeologists like Stuart Pigott, 1950, and Mortimer Wheeler acknowledged and backed this view, 1953. American archaeologists then started to become interested in the archaeology of Indus Valley and surrounding areas in 1950s, and they used the anthropological method to archaeological issues in the areas. Several interpretations that were previously accepted as being roughly true were called into doubt as a result of the advent of this new method. One of these interpretations was the theory of a more wet climate during the Indus Valley civilization. Robert L. Rakes and Robert H. Dyson critically evaluated Stein and Marshall's data in favor of their climate theory in 1961. In the light of the fact that alternate explanations might account for each bit of evidence, they came to the conclusion that the notion of a more humid environment could not be accepted as truth. In 1971, Gurdeep Singh reintroduced the hypothesis of a more wet environment and reignited interest in the topic, with the exception of a feeble methodological defense of the previous theory by Ramaswamy, 1968. Singh's theory differed from that of Stein and Marshall in three important respects. The evidence from climatic change was based on paleontological rather than archaeological data. The climatic change consisted of several fluctuations which covered almost the entire Holocene in northwest India and not just the Harappan period. The fluctuations in rainfall were related not only to the growth and decline of the Harappan culture, but also to the origin of the agriculture-based life in the 8th millennium BCE and to its expansion in the 4th and 3rd millennium BCE in the northwest India. The paleontological evidences from Singh's theory came from 3 salt lakes, namely Sambhar, Didwana, Lankaransar, and one freshwater lake, Pushkar, that is located in Rajasthan. The first 2 lakes are situated in the semi-arid belt with 20 to 50 centimeter average annual rainfall. The third in the arid belt with less than 25 centimeter rainfall, and the last in the semi-humid belt with 50 to 60 centimeter rainfall. The climate evidence from the first 3 lakes only is relevant to archaeological theory. The climate sequence based on the pollen record from these 3 lakes can be briefly summarized as Phase 1 before 8000 BCE. Phase 1, which is represented by wind-borne sand deposits at the foot of lake sediments, was characterized by a harsh environment that, at least during the later half of the last glacial epoch, made it unsuitable for settlements for a very long time. And when we talk about Phase 2, that is the pollen zone B, that started from 8000 BCE and ended in 7500 BCE. Phase 2, it is represented by the first sedimentation in the lakes. Rainfall at this time was at least 25 millimeter more than the present annual precipitation in the western Rajasthan. Phase 3, pollen zone B, it started from 7500 BCE to 3000 BCE. The start of Phase 3, there was a very minor decrease in rainfall, but it was not substantial enough to significantly change the ecological pattern created by Phase 2. Any extraordinary increase in carbonized vegetable remnants in the sediment samples at all sites is a notable aspect of the phase. The emergence of a pollen of Cerealia type coincidences with this search. These 2 facts point to the burning of shrubs, which most likely served as the foundation of the early cereal production. And Phase 4, pollen zone C, from 3000 to 1000 BCE, it was further divided into 3 subphases. 4th A, from 3000 BCE to 1800 BCE, and 4th B is from 1800 BCE to 1500 BCE, and 4th C is from 1500 BCE to 1000 BCE. Subphase 4, pollen subzone between 3000 and 1800 BCE. Rainfall increases fairly abruptly and significantly during subphase 4A. In the arid area, the annual average rainfall during this phase was probably at least 50 centimeter higher than it is now. In this subphase, the Cerealia type pollen that was present in the prior phase continues, as do the carbonized residues that are a result of scrub burning. In chronological terms, sub-area 4A shows the rise of pre-Harappan levels at Kalibangan along with the uninterrupted record of Cerealia type pollen in the pollen profiles and the evidence of forest burning from 3 different sites, which makes one think that perhaps cereal cultivation does not begin with the Indus Valley civilization after all. In fact, it appears that the practice predated Phase 3, as has been stated, and had been prevalent in the area for a considerable amount of time. In fact, one could argue that the notable increase in rainfall at the start of the 3rd millennium BCE, supported by paleoecological evidences, was a major factor in the abrupt expansion of the Neolithic and Chalcolithic cultures in northwest India, ultimately leading to the development of modern civilization. Subphase 4B or pollen subzone C2. Subphase 4B is a short dry period. The Lankaransar lake had started to dry up in the arid area, while the lakes had started to get salty in the semi-arid belt. In the dry and semi-arid areas, the onset of aridity was not simultaneous. Beginning at Sambhar around 1000 BCE and Lankaransar around 2000 BCE. Subphase 4C. Subphase 4C is represented by a slight reversal to a relatively weak wetter interval lasting up to about 1000 BCE. So, effect of aridity on Harappan culture. According to the available data, the Harappan culture in the dry and semi-arid regions of northwestern India likely suffered a decline circa 1800 BCE, but not to the same extent in the culture's outlying regions such as Gujarat and the foothills of the Himalayas. Thus, the Indus culture's demise may have begun with a slow decline brought on by environmental changes, but the process may still have been completed by multiple Aryan invasions from the northwest. Further, this dry period, 2000 BCE and 1000 BCE, as already pointed out, was perhaps responsible for the wide cultural gap between the decline of the Harappan culture and the beginning of the succeeding painted grey ware culture, generally put between 1000 and 600 BCE, tentatively associated with the colonization of impoverished lands, Ghosh, 1952. The weight of analytical and stratigraphic pollen evidence favors a climate determination of the events of this period. When we talk about phase 5, the early centuries to the present. Phase 5 is known only from Lankaransar and is dated in the absence of 14th century dates on the basis of the rate of sedimentation. The pollen assemblage largely reflects the local environment as it is right now. There is virtually any proof that the land has ever been used for the cultivation of cereals, tree vegetation, or the presence of any aquatic species. Overall, the flora appears to be of the typical sand formation kind, currently prevalent in the Lankaransar region. The paleontological and sedimentological findings both point to increased rainfall during the Holocene. A study of the geographic distribution of Harappan sites reveals the following significant findings. As in the case of pre-Harappan farming-based settlements, Harappan sites are conspicuous by their total absence in West Rajasthan, where the lakes that produced climate sequence are located. This area receives an annual rainfall from less than 200 millimeters in the west to 400 millimeters in the east, and similarly, Harappan sites are practically absent on the North Gujarat plain, which is an extension of the West Rajasthan plain. This area receives an annual rainfall ranging from 400 millimeters in the west to 800 millimeters in the east and is drained by the Banas, the Sabarmati, the Mahi and their tributary. The great density of pre-Harappan, early Harappan, mature Harappan, late Harappan and even last sites, painted grey ware and medieval settlements in the Cholistan desert in Pakistan stands in stark contrast to the complete absence of pre-Harappan and Harappan sites of all phases in these two areas. No streams are flowing in these areas right now. It is the driest and most hostile area in the Thar desert with yearly rainfall less than 100 millimeters. If increased rainfall was a causative factor in the emergence of agriculture, in the expansion of farming-based life and in the development of Harappan culture, surely one would expect a greater density of Neolithic and Paleolithic and Harappan sites in the relatively congenial West Rajasthan and North Gujarat plains than in the hyper-arid Cholistan. It can therefore be safely asserted that increased rainfall was not a decisive factor in the rise and growth of the Harappan culture. The densest distribution of Harappan sites is not on the Indus River and its tributaries, but on the extinct Hakra Ghagra and its equally extinct tributaries. More than 530 of more than 800 Harappan sites are found on the Hakra Ghagra. There are probably less than 100 sites left in the Indus Valley proper and in Balochistan if we include the roughly 200 Harappan sites from Kutch, Saurashtra and the about 70 late Harappan sites from the Yamuna Valley in Uttar Pradesh. Decline of Indus Valley civilization. Singh's hypothesis namely that a decrease in rainfall around 1800 BCE led to a decline of the Indus Valley civilization can now be examined. Here it may be incidentally be mentioned that the date of the decline in rainfall is not certain. While at Lankaransar in the arid belt, the lake had started drying up around 2000 BCE, the same event at Sambhar in the semi-arid belt took place 1,000 years later. It is undeniable that in the 18th, 19th centuries BC, Harappan cities declined and some of them were even abundant. In the lower Indus Valley, many causes for these events have been suggested, that is, reduction in rainfall, exhaustion of the economic resources, excessive flooding, Aryan invasion. Additionally, there is an undeniable decrease in both the quality of life and civic ideals. However, the population did not decline as a result of this decline. Only the migration from the Hakra Ghagar Valley into North Punjab, Haryana, and the upper Yamuna Ganga Doab, and from the lower Indus Valley into Saurashtra was compelled. This migration is evidenced by the sudden increase in late Harappan sites in Saurashtra, northeast Punjab, Haryana, and the upper Yamuna Ganga Doab. Rainfall was not noticeably higher in North Punjab and the upper Yamuna Ganga Doab than in the neighboring areas of Punjab and Haryana, which had major human populations during the early and mature Harappan periods. Therefore, the colonization of these new areas could not have given the immigrants any notable advantages. However, the availability of surface and subsurface water in the Ghagar Valley would have been significantly diminished had the Yamuna and Satluj courses been changed to east and west, respectively. This would in due course have adversely affected both natural vegetation and agriculture and forced the population to shift to areas like North Punjab, the Satluj Channel, and the upper Yamuna Ganga Doab, where the rivers provided the ecological conditions the Harappans had long been accustomed to exploit. It is therefore quite unnecessary to invoke the deterioration of climate to explain this migratory phenomenon. In the case of the lower Indus Valley, some or all of the various explanations suggested could have accounted for the shift of the Harappan population into Gujarat. The phenomenon known as degenerate Harappan civilization is an extension of the late Harappans' eastward movement. This would seem to be a result of an overabundance of population pressure on the little available land in the upper Doab. This demographic pressure is clearly demonstrated by the abundance of late Harappan sites in the districts of Ludhiana and Saharanpur. Aridity in the second millennium. The aridity between 2000 and 1000 BC is responsible for the hiatus between the Harappan and PGW painted gravier cultures. Recent excavations by the Archaeological Survey of India at Bhagwanpura in the district of Kurukshetra, Haryana, and Dhaderi in the district of Ludhiana, Nagar and Katpaloon both in the districts of Jalandhar, Punjab, and Manda on the Chenab in Jammu have shown that painted gravier culture coexisted with the late Harappan at these sites. Gupta suggests 1300 BCE for this overlap phase. The new evidence eliminates the heights between the Harappan and PGW cultures and effectively knocks down the bottom out of the desiccation hypothesis of Singh. Even in the North Rajasthan part of the Ghagar Valley, the new evidence available suggests that there was no heights between the Harappan and the PGW cultures. Black and red ware has been found in profuse quantities in association with painted gravier both in surface explorations and in excavations at Sardargarh in this region. Archaeological research during the last 2 decades has amply demonstrated that in northeast Rajasthan and in the central Yamuna Ganga Doab, painted gravier was preceded by an independent phase of black and red ware culture, which in turn at many sites was preceded by OCP or degenerate Harappan. Fresh field research in the Ghagar Valley in Rajasthan and re-evaluation of the older evidences is most likely to show the continuity of occupations in this area from Harappan to PGW. However, there is evidence to show that population during the painted grey ware periods was much sparse in the Ghaggar Valley. In Pakistan, parts of this valley, only 14 sites of this culture have been found, and all this occur in the eastern part, that is southeast of Bahawalpur, near the Indian border. This is in sharp contrast to the dense concentration of mature Harappan sites further down in the same valley. Further, Ghosh has shown that the painted grey ware sites are often located on the Ghaggar bed. These two factors show that during the PGW period, number one, the Ghaggar no longer flowed along the way to the sea, but only in the upper part of its course. And number two, that its original bed had considerably shrunk. This must naturally have been the consequence of the diversion of the Yamuna from the Ghaggar channel to its own present channel. When we talk about significance, the Indus narrative is significant in today's world because it gives us a clear illustration of the potential effects of climate change on humans. The Indus Valley people were wise and had strategies for adjusting to the climate. The study provides a powerful lesson for today as the migration out of Syria and African countries has some roots in climate change. Additionally, the recent sea level rise brought on by climate change may cause massive migrations from low-lying areas like Bangladesh or hurricane-prone areas in the southern United States. The Harappans could adapt the change by migrating, but given the current rigid governmental boundaries and the propensity towards protectionism, this option is all but eliminated in the current global environment, which ultimately could lead to political and social upheaval. So, here concludes our today's lecture. Goodbye and have a nice day.